Okay, here we go. Okay. A. We are going to look at absolute value. We're now changing from an equals to an inequality. So I'm going to say less than a particular number. That's kind of like D for distance. Okay? This could also be an equal to, but we're going to look at this less than category. And the first thing we're going to do is isolate. Seems reasonable, right? And then we're going to think. First two steps are almost always the same. Isolate and think, okay? So the thinking is the part that I'm going to teach you and explain to you how to do. So isolate the absolute value, okay? And then we're going to stop and think. Okay. And we have two choices here. We have an outside choice and an inside choice. And I'm going to explain to you what those things are. Okay, very similar sentence to what we filled out for the equation. The set of x values whose distance from 0 is less than d, right? Less than d. Not equal to, less than. Okay, so we're going to draw a number line. And we're going to think about numbers that could be less than d. Okay? So I'm going to draw my number line right here. There's my 0. There's my d. There's my negative d. Not a smiley or winky face. It's a d. Okay. If you had to shade the inside or outside, now I'm going to put little dots on the endpoints because that's what happens when we had an equal to. Yeah. Now we have an inequality. So do I need to shade outside the dots or inside the dots, and why? Am I going to shade inside the dots or outside the dots? And why? Sasha? Okay, let me give you a more concrete example. Yes? Okay, so let's try this. Okay, I'm going to switch from an abstract example to a concrete example, and I'm going to put 3 and negative 3 and 0. I want numbers whose distance is less than 3. Yeah. Okay, so that was confident. So Maddie said inside. Okay, Sasha, you changed it to inside. Can somebody tell me why I would shade between these endpoints? Go for it. Yeah. 1, 2, 3. 1, 2, 3. I need distances that are less than 3. You cannot count more than 3 little humps. Means you cannot go over here. 1, 2, 3. From the center.
What do you mean by shade outside or
Okay, so I am going to shade inside the endpoints.
So would shade just mean draw that line like?
Yeah, shade is where you color in the solutions.
But why would the circles be closed?
It could be either.
Oh, so it doesn't matter.
Yeah, the endpoints will be specific to the question. Okay, so we're gonna shade inside based on this concrete example that we looked at. Okay, so this is the conclusion to our thinking, yes?
Why can't it go past the -3?
What's the distance from 0 here? Is that more than 3?
Yeah.
So that's not an answer. Yeah? It's a good question. Okay, so part of this thinking means that my answer, so I'm going to write the word and, I'm going to write the word inside, and I'm going to write this inequality. The thinking is what's going to determine how we set up to split and solve. That's what it's going to do. The second step is split and solve. I chose inside because I interpreted the question. The distance has to be less than this number. Well, distance have to go towards the 0 if it's going to be less than. All right, split and solve. Here we go. Example.
How much room do we need for an example?
How much room? I mean, I'm going to take up that much room, so you guys about half that. Okay. Absolute value. 2x plus 6 plus 1, 2, 13. Okay. Yes.
Sorry, but would the and be is the and referring to the circles closed and the inside just means shading in the inside?
And is actually referring to intersection, because
Oh, right.
yeah, yes.
So right off the bat, we know that.
Well, hold on. Almost off the bat. First, before you know how the answer is going to turn out, isolate it, and then you know what your answer is going to look like. But yes, a quarter of the way through the problem, you should already be able to format your answer because you know what's going to happen. Okay, now we know. Okay, here comes my thinking bubble, which is actually a really big bubble because I got a lot of thinking. Can distance be less than 12? Yes. How is my distance going to be less than 12? That means that I've got to go towards the center of the number line. Okay, so that means it has to be between, right? It has to be between -12 and +12 on the number line. So it's between. Okay, so when I move on to the split and solve portion, split, -12, +12. It's got to be between. Yes, question.
So does D just mean the number, like it doesn't mean distance necessarily?
D, yeah, it's the number, but
The
it is,
absolute value.
yeah, that turns into this because the distance has to be less than 12. Okay. Has anyone seen this 3-part thing before? Yeah, a few people. So it's not that crazy. it's kind of like your equation, but you just have two little balance bars. And whatever you do to one section, you do to all of the sections. So I'm going to minus 6 from all 3 sections. And then I'll divide by 2. There's my lovely inequality answer. That is between -9 and 3. Now to go along with this, we're just going to sort of sketch the number line and we'll write some interval notation. 9 and 3. Open circles because it's not including the endpoints. Nope. Shaded between. Notice that this is really 2 inequalities in one. It says x is more than -9, so it's going this way. X is less than 3, so it's going this way. It's the overlap, it's the intersection. All right, lovely interval notation. Okay, you're doing great. Okay, I want you to start the second example without me, and then I will start calling on you to tell me what to do. Okay, so feel free to check in with your neighbors if you need to. So 3 minus the absolute value of x plus 4 plus 2 greater than or equal to -6. So I'll give you a little bit. You're gonna isolate. You got a big thinking bubble. Give you a hint, it should be between. Okay? So just check your steps. It should be between. Okay, you start, then I'll start calling on you for suggestions. Allison, what would you do first? Yeah, subtract 2, okay? So 3 minus, okay. All right, Michelle, next. Yep, -3. Max. Yep, divide by -1. And that is where, okay, when you divide by that negative, okay. Claire, what do I write after this?
You're gonna flip the inequality sign, so it's gonna be less than or equal to
Yes, yep.
+11.
Yes, less than or equal to +11. So we're going from here to here. That's that review algebra. Okay, awesome. Okay, isolate. Now I'm ready to think. Zach, can you give me one thing that we're thinking about? What are you looking at in terms of how do we go forward from here? Okay, yes, but why are you saying that? Can someone help? He's setting it up correctly. All right, you want to help him out, Duncan?
Yeah, so 11 is like your distance, or like kind of your, like that's your range, kind of.
Yeah.
So it'd be like negative 11 is less than g or x is less than positive 1.
Okay, so because we have the absolute value is less than 11, it's yes, I can solve this problem. Because it's less than, it's going to be between, because that's the only way to get distances less than 11 is to shade towards the center. So we're going to get negative 11 and positive 11, right? Those are my endpoints. Am I going to go between them or to the outside? I'm going between them. Equal x plus 4. Okay. Negative 11 is less than or equal to x plus 4 is less than or equal to 11. So the thinking part is how I decided the between because it was less than. All right, so I have split and solve. Okay. Lori, what do I do next?
Next, you subtract 4 from all 3 sides.
Yep. Okay. Fantastic. So we get negative 15. Okay.
Oh, wait.
I probably can't.
Wait, do minus 4. You did minus 1.
Happens. Try that one more time. 7. Okay. Rayon, how do I put this on a number line, or how do I write this in interval notation?
So you put negative 15,
Uh-huh.
and then you do a closed circle,
Okay.
and then you go to 7, and you put a closed circle.
Yep. And then it's in between. X is greater than or equal to negative 15, so that's this way. X is less than or equal to 7 is this way, but it's the and, it's the overlap. Yes, Duncan.
You saying it wouldn't work if it was greater than?
Yes, the 3-part inequality only works this way. That's why I actually read it twice. And when you read your inequality, start with the x. X is to the right of negative 15. Okay, yes. X is to the left of 7. Both statements have to work. And if the inequalities are flipped, it will not read correctly.
So is that kind of like the saying it just doesn't work?
Yeah, so if you set your problem up correctly, it should always work. If you made a mistake, that's when you end up with things that you're like, yes.
I saw in built-in math that there's like 2 ways to like enter your answers this way, and then it has to be like x is greater than or equal to 7, and x is greater than or equal to 11, and you put and in between it. How do you know when to like?
Okay, so the key word I used was and, which implies the overlap. This is the better way to answer it as one inequality as opposed to 2 separate.
Or would it, actually, no, it was or.
Okay, so we're going to do the ors.
Okay.
Okay, so interval notation.
Would it accept it as if you put and instead?
I'm not sure. I'd have to go and check. This is the better way to write it. So if it's an in-between answer, this is how I would expect to see it written, which is the simplified way. Think of your number line. If you shade one piece on your number line, it's one inequality. All right. Whew, you guys are doing good work. Okay, so we're going to do another type here, which is absolute value is greater than a number, or it could look like greater than or equal to, which is not going to change the conceptual understanding. Okay? Here we go. What do? We isolate and then we think. You're going to isolate your absolute value and then we think. Okay, so when we are thinking, we are deciding whether these distances should be going to the outside, away from the center, or to the inside. Okay? Now, we just looked at the inside examples, so I'm going to put a number line here, and we're going to look at it. Okay, so we've got the negative distance and the positive distance. Okay, we got the center. And I'll just use closed points. Okay, so this is where you're equal to D. The distance is equal to D. But now we have to look at distances being more than D. Okay, so if I have, let's do a little concrete example here. If I say this, and I want distances that are more than 3, then I could go 4, 5, 6, 7, 8, 9, 10, 3.1, right? Or I could go -4, -5. Notice that the distance has to be 1, 2, anything that has more than 3 counts from the center has a distance that is more than 3. Okay? 1, 2, I can count more than 3 to the left. So notice that I'm shading outside. Okay, so I'm shading outside because the distances are more than 3. Okay, so this is going to shade to the outside. Okay, so the set of x values, so I'm just interpreting, whose distance from is, okay, from 0 is more than D, more than. So you have to travel more than the endpoint. You have to get to the endpoint and keep going. More than. So I look at that, I'm like, okay, well, I've got my keywords that I have been thinking about, and I'm going to write the word or, because remember that you row your boat with 2 oars. Remember? You row your boat with 2 oars, so you should have an or answer, okay, which means it should be or for outsides. Mnemonic devices and alliteration is awesome. Okay. So what does this look like? All right. X is less than or equal to -D, right? X is to the left of. Or X is to the right of the right endpoint. Look at the graph I shaded. The graph came from me understanding how to shade distances that are more than a certain number. I looked at the graph and then I wrote the inequality that goes with it. Mm-hmm.
So is it like the other one, the x is greater than or equal to b? Is it the sign cool because when like if you were to get rid of the negative sign, you would divide and flip the sign then? Okay.
Mm-hmm. Okay. So notice, yep.
You could say D is less than or equal to X, or is it always X is less than?
I always like to write the x first because that's typically how you read your inequality. When you write your x first, the arrow points the same direction. Yeah. Okay. All right.
But you can write it.
Yeah. Okay, look at this. I want you to, okay, look right here. right? Because we have to pay special attention to what's happening when I set this up. Check that out. What's different between those two things that I highlighted? What? Hold on. You already answered a lot. What's different between the two things I highlighted? Yes. Okay. One is greater than and one is less than. I need another difference. New hands? New hands? Yes. Okay. One is negative and one is positive. So notice how we do the left side. The left side, the negative, the inequality is flipped. That has to do with the setup. Okay, where did the change in direction come from? Because I need to make sure that this left side actually went to the left. Okay. Question or comment? Okay. All right, let's do an example. We've got our thinking. We understand how to get outside, and that's our setup. I suppose that's the split and solve.
How many examples do we have left?
Yeah, we're just going to do one of these, and I may or may not talk about the last thing. I think I probably won't.
Yeah, I don't think we need to.
Okay. So we'll do a 1/2 x minus 3 plus 1. Doot, 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 doot. Okay. Isolate. The general steps are pretty much the same all year. Okay? It's the thinking that we're adding to each piece. McKay, what would you do first?
You would subtract 1 from both sides.
All right, thank you.
Wait, wouldn't it be 2 and not 4?
Yes. Is it Friday yet?
Okay, it's Friday.
Emma, what would you do next? Not times by 1/2. Divide by 1/2 is accurate. Can we say it a different way, Nina? Multiply by 2. Yes, okay, so divide by 1/2 is the same as multiply by 2 over 1. So I'm going to choose the multiply portion. Okay, so times 2 on both sides. Okay. And think. Okay. The distance is greater than 4, which means, okay, I've got to get distances that are more than. So it has to go to the outsides. That is the only way to get distances more than 4. Okay, so I have to split and solve. How am I going to split this? It's going to go to the left of -4, right? To the left of -4, or to the right of +4. Notice that's how you're going to go to the outsides.
But then wouldn't D be negative? Because
I negative the other side.
yeah, so like if you were to divide by -1, then you put the sign in, wouldn't the negative sign go to the D instead though?
Hold on. Does yours say D is greater than or equal to -4? Or sorry, does yours say -D is greater than or equal to 4? Okay. I will come over there and you can ask that question again. Because I think I know what you're saying, but yes. All right, split and solve. So we have to say x minus 3 is going to flip, right? I got to go to the left. Check out that switching. There's the switching, right? Look at what changed. Because I got to go to the left of the negative side. And here, this side is okay. And solve. Okay. Number line. X is less than or equal to -1. Or, because I row my boat with 2 oars, X is greater than or equal to 7. And in case I wanted some interval notation,
You need to put the U between it.
no, the U is just me making a boat.
Okay, do you need the U between the?
These two, yes. There you go. It's me just putting a person in my boat.